Okay, so here is topics to look for part 2. So I'll probably have to do this in 2 videos. So absolute extrema. So whenever you're dealing with absolute extrema, you need the candidates test. All right, an absolute extrema is when they're asking for okay, basically, oh yeah, duh, they're saying it here. So it's a highest slash lowest output on a closed interval. Okay, so the highest or lowest output on a closed interval. And you always need the candidates test to find it. So the rate at which the amount of water in a tank changes is given by R of T. So this is the rate at which the amount of water in a tank changes. So it's given by this function, and this is A prime of T. If I'm letting A be the amount of water in the tank, then this is the derivative because it's the rate of change. If there were initially 20 gallons of water in the tank, okay, so if there were initially 20 gallons of water in the tank, meaning that A of 0 equals 20, right? Because A is the amount of water in the tank. Find the absolute maximum and minimum amount of water in the tank from 0 to 25 seconds. So this is what I mean by closed interval. Like they're telling you absolute max and min, but they've got to give you an interval to find it over. And the candidates test goes like this. Okay, so we've got T, and then over here you put like the function that you're finding the absolute max or min of. And then I'm going to put the endpoints in. And then between here, I need to put the critical numbers, which are where the derivative is 0 or undefined. Okay, so over here we'll say for critical numbers need A prime of T equals 0. So R of T, we need that to equal 0. So this is the rate function, sine of 1 plus T squared. So I'm going to need to use a calculator for this. So I turn on my calculator. That's not working. Turn on this one. Okay, so we go to y equals, and I'm going to graph that function. So sine 1 plus x squared. Okay, now I only care about this function on this interval, 0 to 2.5. So I'll go to my window, so window, and the leftmost x will be 0, the rightmost x will be 2.5. And I want to make sure I'm in radians, which I am. Always radians. Okay, so this is the rate function, and it looks like it's hitting the x-axis at these 2 points, so we're going to have 2 critical numbers. And the way that you find it, I think, okay, yeah, okay, let's just do the 0 thing. Actually, you could do the 0 thing, or you could use intersect. Let me show you how to use intersect for this. For intersect, you have to graph the x-axis. So the x-axis is y equals 0. I think this is like a little bit faster than the... Okay, so see that red line goes over there? And then I go second calc, intersect. I move close to this 0, hit enter 3 times. All right, and I get x is, you know, that. I need to store that. So I go to my home screen, I hit X, and I'll store it. I'm already using A. Whoopsie. So I'll store it. Store. So I hit store right there. Store, I'll store as B. All right, so T equals 1.463, and then just going like this and saying A, our reader should understand that that is stored as A. Now I'm going to have another one, so T equals, no, I started as B. Oopsie. All right, so that's B. And then back to the graph. Okay, let me find this other 0. So second calc, intersect. This is easier for me than the calc 0 thing. So I just move closer to that intersection, and it's approximately this. Home screen X, okay? And then I will store this as C. 2.299. Oh, thank you. I'm recording.
Zach,
just so you know. No, you're fine, you're fine. I should have put a thing up.
he did not get much stuff.
Understandable.
Okay.
And expected. You're fine. See you. Okay, so, and then this one here is C. Alrighty, so, okay, so those are the critical values, B and C. And now we've got to find A of T over here. And guys, the best way to do this is to use this formula. Okay, because we don't know the antiderivative of this. So, so we're going to use A of T equals 20, okay, because that's A of 0, plus the integral from 0 to T, and then in here it has to go A prime, and I like to use W dW. So at time T equals 0, we already got 20. At time T equals B, which is this, we're going to use the formula. So 20 plus the integral from 0 to T R of W dW, because R of W is A prime of T. And then again, 20, what am I doing? Sorry, I'm distracted. Okay, so 0 to B. Okay, so 0 to B. And then 20 plus the integral from 0 to C. All right, and then here, 20 plus the integral from 0 to 2.5. All right, and then you just use Math 9. All righty, so for here, I go Math 9. Or I want to put 20 first. 20 plus Math 9. 0 to B. Sine. Okay, so this is 21.179. You want 3 decimal places. And then I could just go second enter. All right, so I just hit second, and then enter, and it does the same thing again. And then I can go back here and change that B to a C. Okay. 20.653. And then again, second enter. And then 2.5. 20.742. Now they're asking for the absolute max and the absolute min. So the absolute min, we could just go like this. Oh, and we should say gallons. All right, I should have put the gallons inside the box. All right, that's absolute min. And then this many gallons is the absolute max. Okay, so that's how you show work for that. Now this part, guys, I'm not leaving nearly enough room to do this. Okay, so separate sheet in second video. Okay, so I'll do a separate sheet in the second video, and I'll write the notes out so you don't have to take them. Okay, now these types of problems are rate in, rate out problems. So a water tank at Camp Newton holds 1,200 gallons of water at time t equals 0. So 1,200 gallons of water at time t equals 0. So let me say, I'll use A for amount. So the amount of water in the tank at t equals 0 is 1,200. During the time interval 0 to 18 hours, water is pumped into the tank at this rate. So guys, this is the rate in, okay, W of t. During the same time interval, water is removed from the tank at this rate. So this is rate out. So this is a classic rate in, rate out problem. Is the amount of water in the tank increasing at time t equals 15? Why or why not? If you remember Susan's table, a function is increasing when its derivative is negative. All right? So you need to figure out if the derivative is positive or negative at 15, at time t equals 15 hours. So up here I'll say that a prime of t is going to be equal to the rate in minus the rate out. So a prime of t is equal to W of t minus capital R of t. Okay, so we've just got to figure this out. So we need a prime of 15 and figure out what that is equal. And you just plug it into your calculator. So it's going to be W of 15 minus R of 15. And then we'll get that in a minute. It's kind of a lot to type. So 95 radical 15. Now I'm going to square this sign. Oopsie, so I don't even want that. Delete, delete. Okay, I need to hit over. So I have to square the sign, so I'm putting it in parentheses. Sine 15 over 6 squared. That's the rate in, minus 275 sine, and you could use like alpha y equals, so, and go like, and get that. And that's 15 over 3, and then you gotta square that. Okay, and we get negative 121.090, and that's a rate. So this is gallons per hour. And then, okay, so is the amount of, all right, is it increasing? Okay, so no, the amount is not increasing because a prime of 15 is less than 0. Okay, so that was part A. Now part B. To the nearest whole number, how many gallons of water are in the tank at time t equals 18? So we want to know A of 18 equals what? Equals what? Okay, so let's find A of t, a function for it. So A of t is equal to A of some number we know, which is 0. So we know A of 0 is 1,200. So 1,200 plus the integral from, so whatever input gave you this has to be the lower limit to t. And then in here, we're going to have, okay, in here we're going to put A prime. I usually say A prime of W I usually use W as the placeholder in these, but we are already using W, so let me use like Z. So A prime of Z dz. All right, as long as this placeholder is not the same as the input variable. And then down below, so I'm going to say, actually, let me write this again. So to be more specific to my reader, this is 1200 plus the integral from 0 to t. What is A prime of Z? It's going to be W of Z minus R of Z dz. Okay, and then, so we're going to get A of 18, which is going to give us our answer, 1200 plus 0 to 18, W of Z minus R of Z dz. Okay, and then I just have to plug that into my calculator. Gosh, I wish there was a way of like, okay, let me see. Math, all right, so it's going to be 1200 plus math 9. I wish there was a way to cut and paste. I mean, okay, let me just try something. Could I hit and nah, that didn't. Wait, did it work? Stop. Don't even tell me that worked. No, it just put it in the upper limit. Wait a minute. Clear. Okay. 1200 plus math 9. 0 to, you did not, and I am making a video, so just so you're aware. Yeah. Okay, see you later. 0 to 18. Okay, let me see. If I put that there, and then I go up here, and then I hit enter. Yes! Guys, it went right into where I had the cursor. Oh my gosh, that's so much easier. So we can cut and paste. All right, now instead of this 15 though, we got to put an X. That's so much easier. Yeah, instead of the 15s, I'm putting X's. X. Oh, 1X is fine. And then at the end, dx. Oh, that makes our lives so much easier. Yep, that's it. So 1309.788 gallons. Okay, that's the amount of water, so that's gallons. Okay, so moving on. Derivative of an antiderivative with an integral. Okay, so antiderivative with an integral, anytime you see a function that looks like this, it is always of the form f of x equals f of some number a plus the integral from a to x f prime of w dw. So basically, whatever this function is, its derivative is the input of the integral. Okay, but anyway, we have a fast trick for this, and it goes dt, and then top goes in for placeholder. So f prime of x equals the derivative of the top. The derivative of x is 1 times the top goes in for the placeholder. The placeholder is t, so it's 1 over 2 plus e to the x. Okay, so f prime of x is 1 over 2 plus e to the x. All right. And with a case like this, if it's just x, you don't need to do the dt because the derivative of the top is just 1. So over here, derivative of the top goes in for placeholder. So for this one, we have to do the derivative of the top because the top is a function of x, not just x. So f prime of x is 2x times, top goes in for the placeholder, so cosine of x squared. So there's those. Okay, now verifying differentiability. Okay. All right, so need one, f is continuous. I didn't even read the problem yet. Okay, so is f of x, which is absolute value of x minus 3, differentiable at x equals 3? Explain. So we need to see two things. Number one, we need f to be continuous at x equals 3. If it's not continuous there, then we can stop. It can't be differentiable there. And then number two, we need the, we need f prime. We need f prime to be continuous. No. Yeah? No, let me write what we need. We need the limit as x approaches 3 from the left of f prime of x to equal the limit as x approaches 3 from the right of f prime of x. Okay, so first of all, guys, if it's something like this, I know there's the 3 conditions of continuity, but you don't even have to check it. Because if you can explain in another way that this is continuous, then you're good. So I'm going to explain it this way. I'm going to explain it this way. I'm going to say f is continuous because y equals x minus 3 is, what is it? It's linear. And then what are we doing to x minus 3? We're taking its absolute value. And the absolute value of a linear function is continuous. So what you can do, like if you know that that is continuous, then you could just describe the function in as great detail as you can with math vocabulary. Like if this were x squared plus 5x minus 7, you could say, well, that's a quadratic. So a quadratic function is continuous, or a polynomial is continuous. So here I'm just using some math vocabulary. Linear, absolute value, I'm describing this. F is continuous because this is linear, and the absolute value of a linear function is continuous. And here's another reasoning. Okay, so f of x equals the absolute value of x. That looks like this, continuous, no breaks. G of x looks like that, that's a line, continuous. Both of these are continuous. And then when you take the absolute value of this linear, what you end up with here is called a composition of continuous functions. And this is a fact. Composition of continuous functions is continuous. I've never mentioned it before. So you don't have to show the bullet points of continuity if you feel confident in explaining, yeah, that's continuous because of the type of function it is. Okay, so there's number one. Now, for number two, showing the differentiable part, if you're going to take the derivative of an absolute value, which I'm going to talk about over here on the separate sheet, basically you have to split it up into a piecewise function. So you can't take the derivative of an absolute value function without splitting it up into piecewise. So x minus 3, you take the input of the absolute value. Where is it 0 at 3? To the left of 0, like a number 0. Okay, so pick like 0. Plug it in here, we get a negative. Plug in like 5, you get a positive. So on this interval, the input is negative. On this interval, the input is positive. So basically, we're going to negate this on this interval, and we're going to keep it positive on this interval. So it's negative x plus 3 for x is less than or equal to 3. And it's positive x minus 3 for x is greater than 3. Now, it doesn't matter where you put the less than or equal. It could go up here or it could go there, but it can't go with both. Because if it's with both, then it's not a function anymore, because you'd have, what would you have? Every input needs only one output. So yeah, something like that. But you can only include one of these. You want to include 3 as an endpoint, but you can only do it on one of those. Okay, and then for f prime of x, you just take the derivative of these. What's the derivative of this? It's -1. What's the derivative of this? It's +1. So it's -1 for x is less than 3. +1 for x is greater than 3. Notice I dropped the or equal to because if the derivative does not exist here, meaning it's not differentiable here, the function's not differentiable here, then I wouldn't want an or equal to because the derivative wouldn't be equal to anything at an input of 3. Okay, if I find out in a minute that that these limits are equal, then I could put in the or equal back there if I want to. All right, so now the limit as x approaches 3 from the left of x prime of x. So 3 from the left, so like 2.9, 2.99, 2.9999. It's this constant function -1. And then the limit as x approaches 3 from the right. So like 3.1, 3.01, 3.0001, 3.000001. So now the y values are staying at 1, which we could say, so the limit is 1. So we'll be like, no, f of x is not differentiable at x equals 3 because the limit as x approaches 3 from the left of f prime of x is not equal, oopsie. Okay, so there is that. The video quality is much, much better today. So that's good. Okay, now, I got a few more minutes. Area and volume, we just did this. This was unit 6. So you need to know these formulas. Vertical slices, area, this formula, volume, this formula. Horizontal slices, area, this formula, volume, this formula. So I probably have time to do the first one. Okay, so read the problems and ask area or volume in which formula. Find the area bounded by the 3 curves below. Okay, so the x-axis, y equals radical x, which looks like that. And y equals 6 minus x, which, okay, so 6 would be the y-intercept, and it has a slope of -1. Ah, oh shoot, I did this wrong earlier. Because I did this, I thought it was the y-axis. All right, so anyway, it's this area that we are looking for. Okay, so, and guys, you're gonna do top minus bottom, but notice top minus bottom here. You could do right minus left, actually. That would work also. That'd be kind of nice. Okay, if you did right minus left, you would just need one integral. But if you did top minus bottom, you would need 2 integrals because here, the top function, bottom function, and then over here, the top function is different from that bottom function. And where do they change? They change right here at this intersection point. And I'll tell you what it is, just to save time. It is 4, 2. Okay, so 4, 2. All right, so actually you could use either one. I guess I'll use top minus bottom. So, so now I need to know this, y-intercept. All right, so this is where y is 0, so that's got to be 6. Or that's an x-intercept, so that's got to be 6. Okay, so area equals the integral. So I'm using, all right, so let me number these. 1, 2, 3, 4. Which formula? Number 1, so I don't have to write it over. All right, it's going to be the integral from 0 to 4. Top minus bottom is radical x minus 0 dx plus the integral from 4 to 6. This time the top is 6 minus x and then minus the bottom minus 0. You don't have to write in the minus 0. Okay, then FTC or Math 9. Okay, it depends on how they ask. And we get that the area is, I'm just going to use Math 9. FTC is very good for this, but I'm just trying to save time. So Math 9, 0 to 4, radical x dx plus Math 9, 4 to 6, 6 minus x dx. What do we get? Okay, 7.333. Okay. Do I have time for another? I would be rushing. Okay, so let's stop here. So there will be 2 videos.